This is question number 7 of homework 4 for session 5 on the security valuations. So we have a question here is non-constant growth rate. And we have a young startup company. No dividends will be paid on the stock over the next 9 years because the firm needs to plow back its earnings to fuel growth. And that's actually what typically happens to a young firm. Only until the firm becomes mature and where it begin to pay dividends. The company will pay a $12 per share dividend 10 years from today and will increase the dividend by 4% per year thereafter. If the required return on the stock is 13%, what is the current share price? And this question shows that even if the firm doesn't pay dividends for now, we can still use the dividend growth model to value its common stock, but we need to apply this model correctly. So just to help you to understand what's going on, let me draw a chart, and here it's what's going on. So this is my starting point, 0, and this is year 9. So in between, there's no dividend payment, and the question says the first dividend actually starts at year 10. So this is D10. That equals, just go back to the setup, check out the numbers. So it's going to be $12 per share. So it's a very huge number there. So this is $12, and this continues, right? So and we're told the dividend growth rate, going back to the setup, is increased dividend by 4%. Yeah, so the dividend growth rate, small g, is 4%. And so, and required return, which is R, that's 13%. 13%. And one thing we need to, and then the starting point to solving this question is to the realization that the dividend growth model, DGM, right, states that the intrinsic value of a stock equals V0, right? V0 equals D1, dividend next period, divided by R, required rate of return, minus the growth rate of dividend. So this is the formula, assuming that the dividend starts from next period. Right? Or the numerator here, actually, to be more precise, here the numerator is the dividend from next period. So if we want to use this model, if we want to use this formula in this setup, we have to realize that the V we are calculating is not in terms of the current period. It's actually in terms of year 9. Why is that? Because when we stand here, D10 becomes the next dividend. So that's exactly is what the numerator requires. So that's the first realization. So basically we are calculating V9, V subscript 9. And V9, let me write down here, V9 equals D10 and divided by R minus G. But the question is not asking us what is the projected stock price 9 years from today. Actually, it's asking us what is the current share price, right? So once we have this V9, we can further discount that back to the true present to get V0. How do we do that? We just apply the present value or the formula for the present value of a single future value. So relative to the true current 0, 9 is the future, right? Year 9 is the future. So once we have V9, V0 is simply V9 divided by 1 plus R, right? So basically I'm applying R as a discount rate in using the terminology of the Section 3 on the time value of money, right? And then the power here is 9 because there are 9 years between now and year 9. So that's how we solve this question. And with this understanding, now I can just plug in this into my whatever tool you use here. I prefer to use Excel, but you can use any tool like calculator or even table. I believe here the table can be used because all the discount rate is integer numbers. But here I prefer to use Excel. So it's $12 divided by 13%, right? It's the required return is 13%, and then minus this G, which is 4%. So that gives me V9, but we're not done because we need to figure out V0. So the relationship between V0 and V9 is that V0 equals V9 divided by 1 plus 13% and raised to the power of 9. So going back to the decimal requirement, right? Here it asks us to round your answer to 2 decimal places. And also by using Excel, I automatically also meet the first rounding requirement. Do not round intermediate calculations, right? So here I just need to format the cells just to keep 2 decimal places. And then we're done. So for 44.38, so now it's time to put that back to the Connect and check my work and see whether I got this right. And turns out, yes, we did.